Assalamu alaikum and hello everyone. Welcome to my lecture on research steps, formulating and clarifying the research problem. I'm Dr. Zaidi Sahad from the Faculty of Information Science at UITM. Before any research project begins, we must ask a simple question: what exactly is the issue we're trying to understand or solve? Your research problem is like a compass. It keeps your study focused and gives purpose to every method, survey, and analysis that follows. When the problem is clear, the rest of your research, your objectives, questions, and data will naturally align. In this lesson, we'll learn how to move from a broad idea to a specific, researchable question that truly matters. As you listen, think of a topic you're curious about, something in your field that still feels unexplored. Let's take a quick look at what we'll be exploring today. First, we'll define what a research problem really means and why it's so important. Next, we'll learn step by step how to formulate one, from choosing a topic to narrowing it into a clear statement. After that, we'll connect the dots between your problem, your research objectives, and your research questions. We'll also see how to create operational definitions, which simply means turning big ideas like engagement or readiness into something we can observe and measure. Finally, we'll end with how to frame problems in qualitative research, where we focus on people's experiences and meanings rather than numbers. Each part builds on the previous one, so by the end, you'll have a full roadmap to begin your own project. By the end of this topic, you'll be able to do three key things. First, identify a clear and researchable problem in your area of interest. Second, develop good research objectives and questions that flow logically from that problem. And third, evaluate whether a problem statement is realistic, significant, and clearly written. These skills will help you design a focused proposal and later write a strong thesis or report. Remember, a well-defined research problem isn't just an assignment requirement, it's what gives your study value and direction. As we move along, keep thinking, what issue in my discipline could benefit from deeper investigation?
So, what exactly is a research problem? In simple terms, it's a question, gap, or challenge that needs to be explored through systematic study. It could be something we don't yet understand, a process that isn't working well, or a theory that doesn't match reality. Cresswell describes it as the foundation of any research, the reason the study exists in the first place. For example, imagine librarians adopting new AI-based catalog systems. If users aren't engaging with them as expected, that's a potential research problem. The key is that the problem must be specific, clear, and meaningful enough to deserve investigation. Think about it: if you can express your research problem in one simple sentence, you've already taken the hardest step. Now, where do good research problems come from? Often, they appear when reading, you'll notice contradictions, unanswered questions, or missing perspectives in previous studies. Real-world practice also reveals them. For example, maybe a university library has advanced digital tools, but student usage remains low. That's a real issue worth studying. Policy documents and government reports can highlight national priorities, like open data sharing or digital transformation, that spark new research ideas. Emerging trends such as AI in education or data privacy concerns can also uncover timely topics. And finally, don't underestimate personal curiosity. Many great studies start with a simple thought: why does this happen? Or, what if we did this differently? So, as you continue your academic journey, train yourself to see everyday challenges as potential research opportunities. There are generally three main types of research problems, and knowing which one fits your study helps you choose the right design. The first is a practical problem, which focuses on real-world issues that require solutions. For example, imagine the inefficient adoption of open data systems in public libraries. That's a practical challenge calling for better strategies or interventions. The second is a theoretical problem, which relates to gaps or inconsistencies in existing theories. Perhaps there's no clear model explaining user trust in AI-based information systems. That signals a need to refine or expand current theory. The third type is an empirical problem, which needs data or observation to confirm relationships or outcomes. For instance, you might want to test whether data quality influences research productivity. Recognizing which type of problem you're addressing, practical, theoretical, or empirical, helps you decide your methods and the overall direction of your research. A strong research problem must have several key qualities that make it clear, focused, and achievable. First, it should be clear and specific, not too broad or vague. You should be able to state in one or two sentences exactly what issue you want to explore and why it matters. Second, it needs to be researchable, meaning the problem can actually be investigated using available data, tools, and research methods. If it can't be observed, measured, or analyzed, it's not truly researchable. Third, your problem should be significant. It must address an important issue, contribute to new understanding, or help improve professional practice. Fourth, it has to be ethical, something that can be studied responsibly, without causing harm to people or violating privacy or institutional guidelines. And finally, it must be feasible, realistic within your time frame, budget, and access to resources. When a research problem meets these 5 qualities, you can be confident it is both meaningful and doable, a solid foundation for your entire study. Let's walk through the process of formulating a research problem, the part where your general idea becomes a clear question that leads your entire study. Step 1. Identify a broad topic. Start with something that truly interests you, such as open data in digital libraries. This broad area gives you direction. Can you already think of one broad topic from your own field? Step 2. Conduct a preliminary literature review. Read earlier studies to understand what has been done. Maybe you discover that while many authors discuss open data benefits, very few examine how librarians actually apply those policies. Does that kind of research gap sound familiar in your area? Step 3. Narrow the focus. From what you've learned, find the gap or unresolved issue. For instance, you might notice low adoption of open data practices among librarians. Narrowing keeps your study realistic and manageable. Step 4. Ask why and how questions. Ask, why is this happening? And how does it affect stakeholders such as researchers, students, or library users? These questions help uncover deeper reasons and impacts. Wait a minute, could you write one why or how question for your topic? Step 5. State the problem clearly and concisely. Combine what you've discovered into 1 or 2 short sentences. For example, although open data initiatives exist, many librarians struggle to implement them effectively, limiting collaboration and transparency in research. And that's it. By following these 5 simple steps, you turn curiosity into a focused research problem. Is everyone following so far? Good. Let's test this process with a real example in the next slide. Let's go through this example carefully to see how a broad topic gradually becomes a clear research problem, using open data in digital libraries as our case. Step 1. Identify a broad topic. Choose an area that genuinely interests you or connects with your field of study. Here, the topic is open data in digital libraries. Can you think of one broad topic from your own discipline that you would like to explore? Step 2. Conduct a preliminary review. Read the literature and examine relevant policy documents to spot any gaps or contradictions. For example, you might find that few studies have assessed the data sharing culture among Malaysian librarians. Have you ever noticed a similar gap while reading journal articles? Step 3. Narrow the focus. Define a specific issue within that topic. In this case, the focus becomes low adoption of open data practices among librarians. Narrowing your scope helps make the research more achievable. Step 4. Ask analytical questions. Use why, how, and what to clarify the issue. For instance, why do librarians hesitate to share data? Such questions guide your investigation and shape your data collection approach. Step 5. Evaluate significance. Ask yourself, who is affected by this problem, and what will this study contribute? Here, the research addresses a policy gap in library data governance, a valuable and relevant contribution. Step 6. Write the problem statement. Finally, craft a short, clear statement that summarizes the issue. For example, although open data policies exist, limited librarian participation indicates barriers to implementation. Through these 6 simple steps, identify, review, narrow, question, evaluate, and write, you can transform a broad idea into a focused, researchable problem. Are you still with me so far? Try to imagine how these same steps could apply to your own topic. Let's now look at another example, this time using artificial intelligence in libraries to see how a broad idea becomes a research problem. Stage 1. Broad topic. We begin with a general theme, artificial intelligence in libraries. This gives the study a wide but relevant starting point, something many students and professionals can relate to. Stage 2. Narrow focus. Next, we narrow it down to a specific area, AI tools for improving user engagement. Rather than trying to study all applications of AI, we focus on one key aspect that directly affects users. Can you see how narrowing the topic helps make it more manageable? Stage 3. Identified gap. After reviewing the literature, we notice a limited understanding of how librarians adopt AI in daily operations. Many studies talk about the benefits of AI, but fewer examine librarians' readiness, training, or comfort levels in using it. This gap becomes the basis for our research focus. Stage 4 Problem Statement. Now we can form a clear and concise problem statement. For example, despite the rapid adoption of AI in library systems, there is limited understanding of librarians' readiness and capability to use these tools effectively to enhance user engagement. Notice how this statement identifies the issue, specifies who is involved, and highlights why it matters. By following this simple process, from broad topic to narrowed focus, to identifying the gap, and finally writing the statement, you create a strong foundation for your study. Now, please think, how could you apply these same stages to your own research idea? Let's now see how a clear research problem can be derived directly from the literature review. When we read earlier studies, we're not just gathering facts, we're also identifying what has not been fully explained or explored. In this example, studies show that AI applications such as chatbots and recommendation systems are increasingly used to enhance library services. Luo, 2022, Khan and Singh, 2023. These tools are proven to improve user engagement and streamline information access. However, despite these benefits, many librarians still lack training, skills, and confidence in applying AI effectively. Tan and Suley, 2023, Ishmael, 2024. This shows a clear gap in understanding how librarians actually adopt and integrate AI tools into their daily work. From this observation, we can now formulate a problem statement derived from the literature. Although artificial intelligence technologies are increasingly used in library services to enhance user engagement, many librarians still face challenges in adopting and applying these tools effectively. Previous studies emphasize the benefits of AI applications but provide limited insight into librarians' readiness, skills, and attitudes toward implementation. This gap highlights the need to examine librarians' capability and preparedness in leveraging AI tools for improving user engagement. This leads us naturally to the topic: librarians' readiness and capability in adopting artificial intelligence tools to enhance user engagement in academic libraries. As you review literature for your own topic, try asking, do these studies agree, or is there a missing piece? That missing piece, the unexplored link, is often the beginning of a strong research problem. Once we've clarified the research problem, our next task is to define what we aim to achieve and what questions or hypotheses will guide our investigation. This is where the research objectives come in. A research objective clearly states what your study seeks to accomplish. It translates a broad research problem into specific, actionable goals that can be measured or tested. Think of it as a bridge. It connects the problem statement to the methods you'll use to solve it. There are two main types of objectives. The first is the general objective, which expresses the overall aim of the study. For example, to examine librarians' readiness and capability in adopting AI tools. This statement gives the study its big picture direction. Next, we have specific objectives, which break that general aim into smaller, measurable steps. For instance, to identify the level of readiness among librarians, to assess their capability and skills in using AI technologies, to determine the factors that influence AI adoption in academic libraries. Each objective should begin with a clear action verb like identify, examine, evaluate, or determine. Together, these objectives serve as your roadmap. They ensure your study remains focused, systematic, and purposeful. Before we move on, take a moment to check. If someone reads your objectives, can they easily tell what your research hopes to achieve? If the answer is yes, your objectives are well defined. In the next part, we'll look at how these objectives naturally lead to research questions and hypotheses, which specify how you'll explore or test each goal. After defining your research objectives, the next logical step is to craft your research questions, often abbreviated as RQ. A research question is a specific, focused query that your study seeks to answer. It comes directly from your objectives and serves as the backbone of your entire research design, guiding everything from data collection to analysis. The purpose of a research question is threefold. First, it helps clarify what you really want to find out. It turns a broad aim into a precise inquiry. For example, instead of saying, to study AI in libraries, you ask, what is the level of librarians' readiness to adopt AI tools? Second, a research question ensures that your study stays focused and relevant to the identified problem. It acts as a compass, reminding you not to drift away from your main issue. Third, it guides your choice of research methods. If your question asks how or why, it usually leads to a qualitative approach. If it asks to what extent, how much, or is there a relationship, it points toward a quantitative study. Well-written research questions are clear, specific, and answerable. They tell readers exactly what the study is trying to uncover. Before you proceed, pause for a moment and ask yourself, can you state your own research question in one sentence that anyone could understand? If you can, you're already one step closer to a strong and well-structured research design. Now that we know what a research question is, let's look at the different types you can use. Each type serves a distinct purpose, depending on what you want to discover. The first type is a descriptive question. This type simply asks you to describe characteristics, conditions, or situations. For example, what is the level of librarians' readiness to adopt AI tools? It doesn't compare or test anything. It just helps us understand what currently exists. Take a moment and think, what could you describe in your own topic? The second type is a comparative question. Here, we look at differences between groups or situations. For instance, does readiness differ between senior and junior librarians? This kind of question helps highlight variation. It tells us if one group behaves or perceives things differently from another. The third type is a relational question. This one explores the link between two or more variables. For example, how does AI literacy relate to user engagement? Relational questions are especially common in quantitative research because they test correlations or predictive relationships. Finally, in qualitative research, questions are open-ended and exploratory. They aim to uncover meanings, feelings, or experiences rather than numbers. For instance, how do librarians perceive the use of AI in enhancing user engagement? Notice the wording here. It invites explanation and reflection, not measurement. So, whether your study describes, compares, relates, or explores, your question should clearly match your purpose. Ask yourself, which type best fits my study: descriptive, comparative, relational, or exploratory? Now that we've discussed research questions, let's talk about hypotheses, often written as H1 or H0 in quantitative studies. A hypothesis is a tentative answer or prediction about the relationship between two or more variables. Basically, it's a statement you can test statistically. While research questions ask, what might be happening? A hypothesis predicts, this is what I expect to find. The purpose of a hypothesis is twofold. First, it allows you to predict outcomes that can later be verified or refuted through actual data. This gives your study a sense of direction. You're not just exploring, you're testing something specific. Second, it provides a clear framework for quantitative testing. For instance, if your research question is, how does AI literacy relate to user engagement? Your hypothesis might state, higher AI literacy among librarians is associated with greater user engagement. This is something you can measure using surveys, correlation tests, or regression analysis. A good hypothesis should always be clear, concise, and testable. It shouldn't rely on personal opinion or vague ideas. It must be something that data can confirm or reject. Before moving on, ask yourself, can my research problem be expressed as a statement that could be tested statistically? If yes, then formulating a hypothesis will give your research a strong and measurable direction. In the next slide, we'll look at the types of hypotheses, how to distinguish between the null and the alternative forms. Now that we understand what a hypothesis is, let's look at the two main types you use in quantitative research: the null hypothesis and the alternative hypothesis. The null hypothesis, written as H0 or H0, states that there is no relationship or no difference between the variables you're studying. It represents the idea that any observed effect is simply due to chance. For example, H0, there is no significant relationship between AI literacy and user engagement. In other words, librarians' level of AI literacy does not appear to influence how users engage with library services. The alternative hypothesis, written as H1 or H1, predicts that there is a relationship or a difference. For instance, H1, higher AI literacy among librarians is associated with greater user engagement. Here, you're suggesting that the two variables move together. When one increases, the other is likely to improve as well. In most statistical testing, we start by assuming the null hypothesis is true and then use data to see whether there's enough evidence to reject it in favor of the alternative. So, your research doesn't aim to prove something instantly. it tests whether your prediction holds up against real evidence. Before we move on, take a moment to think. Can your own study express its main idea in both forms, one that assumes no relationship, and one that predicts there is one? If so, you already have the basis for sound hypothesis testing. Now that we've covered both research questions and hypotheses, let's look at how they differ, and how they complement each other. A research question is used to ask what you want to discover. It is exploratory and investigative in nature. For example, what factors influence librarians' adoption of AI tools? Here, you're seeking understanding rather than prediction. Research questions are commonly used in qualitative or mixed method studies, where the goal is to explore experiences or explain phenomena in depth. A hypothesis, on the other hand, is used to predict what you expect to find. It's testable and measurable, based on an assumption you can verify with data. For instance, librarians with higher AI literacy are more likely to adopt AI tools. This statement can be statistically tested, making it typical of quantitative research. So, to put it simply, a research question asks, what is happening or why does it happen? A hypothesis says, I think this is what will happen. Both are equally important. One seeks discovery, the other provides prediction, and together, they give your study both depth and direction. Take a moment and think about your own topic. Are you asking open questions to explore, or forming hypotheses to test relationships? Knowing this distinction helps you choose the right research design and analysis approach. Before we discuss this slide, take a moment to read the table on screen. Notice how each research objective aligns closely with its corresponding research question, and sometimes, a hypothesis. Look at how the language shifts slightly, from what the study aims to achieve, to what it wants to find out, and finally, to what it expects to discover or test. In simple terms, the research objective describes what you plan to achieve. The research question asks what you want to find out. The hypothesis predicts what you expect to happen. However, not every study requires a hypothesis. In certain research paradigms, especially descriptive, exploratory, or qualitative studies, hypotheses are not necessary because the goal is to observe, describe, or understand rather than to test relationships. For example, if your study simply measures librarians' readiness or explores their experiences, you would stop at the research question stage. That said, hypotheses are common in quantitative or causal studies, where you're testing measurable relationships or differences. And remember, while traditionally linked to quantitative methods, hypotheses can also serve as guiding assumptions in qualitative or mixed method designs when they help structure inquiry. Now, take another look at the table. Can you see how each row connects purpose, question, and prediction, and how some rows stop at the question level because no hypothesis is needed? That's how proper alignment ensures a clear, logical, and methodologically consistent research framework. Let's move on to an important part of research design, the operational definition. An operational definition explains exactly what you mean by a concept in your study and how you plan to measure it. It takes broad or abstract ideas and turns them into something concrete, measurable, and understandable for everyone involved. Why is this important? First, it ensures everyone interprets the concept the same way. For example, if you mention user engagement, you need to be clear about what that means in measurable terms. Second, it helps you collect data consistently. When all participants or researchers use the same definition, your results become more reliable. And third, it translates big ideas into observable indicators, things you can actually count, test, or analyze. Let's look at a simple example. The concept is user engagement. Its operational definition could be the number of times a user logs into the library website per week. Here, a broad concept has been transformed into a clear and measurable variable. So remember, an operational definition gives precision to your research. It's what turns ideas into data. Pause for a moment and think, how would you define the key concepts in your own study so that others could measure them in exactly the same way? Now that we know what an operational definition is, let's see how to create one step by step. Step 1. Identify your key concept. Start by deciding which idea in your study needs to be measured or observed. For example, your key concept might be readiness to adopt AI. Choosing the right concept is crucial because it sets the direction for what kind of data you'll need. Can you think of one key concept from your own topic that you'd like to measure? Step 2. Describe what it means in your study. Here, you explain how you define that concept within your context. In this case, being ready might mean being willing and confident to use AI tools in daily library tasks. Notice how this step moves from theory to your specific research setting. It makes the idea relevant and contextual. Step 3. Decide how to measure it. Finally, choose the tool or indicator that will let you collect data consistently. For example, you could use a Likert scale survey, where participants rate their readiness from 1 equals not ready to 5 equals very ready. This converts an abstract concept, readiness, into measurable data you can analyze statistically or descriptively. When you follow these 3 simple steps, identify, describe, and measure, you make your research more precise, transparent, and replicable. Take a moment and think, how would you measure the key concept in your study? Let's look at some easy examples of operational definitions to see how abstract ideas can be turned into things we can actually measure. First, the concept of AI literacy. Here, it's defined as a librarian's ability to use AI tools. To measure it, you could give a short AI skills quiz and score each participant. This makes a general idea like literacy concrete and measurable. Next, we have readiness. In this context, readiness means the willingness to adopt AI tools. You could measure it using a survey scale from 1 to 5, where 1 means not ready and 5 means very ready. Simple, consistent, and easy to interpret. The third example is user engagement. We define it as how often users interact with AI services, and we can measure it by counting the number of chatbot uses per month. Here, frequency becomes a direct indicator of engagement. And finally, organizational support. This refers to how much backing librarians receive from their management to use AI tools. It can be measured by checking for the presence of training opportunities or dedicated budget allocations. Notice how each concept is clearly defined and paired with a measurable indicator. This ensures that anyone reading your study understands exactly what each term means, and how it's assessed. Now, think about your own research. How would you define and measure the key concepts in your topic? Let's now look at how a qualitative research problem is formed. Unlike quantitative studies, which focus on numbers and measurements, qualitative research aims to understand people's experiences, opinions, and feelings in depth. A qualitative research problem is essentially a question about human experience, something that needs to be explored rather than measured. Its key focus is on understanding, not on counting or testing. It seeks to answer how or why something happens, rather than how many times it happens. And instead of dealing with statistics or percentages, qualitative studies work with words, stories, and meanings, the rich, descriptive side of human behavior. Here's a simple comparison. A quantitative question might ask, what percentage of students use the digital library? But a qualitative question would ask, how do students describe their experience using the digital library? See the difference? The first looks for a number, the second looks for understanding. So, when formulating a qualitative research problem, think about what needs to be explored, understood, or interpreted, rather than what needs to be measured. Pause for a moment and ask yourself, in your own topic, what, how, or why question could reveal deeper meaning about people's experiences. Now let's go through the steps for formulating a qualitative research problem, a process that helps you move from curiosity to a meaningful question for exploration. Step 1. Choose a broad topic you're genuinely curious about. It could be something like library services and technology. Start broad. This gives you room to notice interesting human issues within the topic. Think for a moment, what general area sparks your curiosity? Step 2. Find an issue or situation that needs understanding. For example, students are using the library less, but we don't really know why. This kind of why signals that something deeper needs to be explored. Step 3. Focus on the human side. Ask about people's feelings, opinions, or experiences. Maybe you want to know how students feel about using online library resources or why some avoid them altogether. Qualitative research values these perspectives and emotions. Step 4. Turn it into an open-ended question. For instance, how do students feel about using online library resources? Notice how it invites explanation rather than a simple yes or no answer. When forming your qualitative question, always use words like how, why, or what kind of experiences. These invite stories and meaning instead of numbers and statistics. Let's look at a few examples of qualitative research problems to see how they're framed. Notice that each one focuses on people's experiences, perceptions, or feelings rather than numbers or percentages. The first broad topic is online learning. Here, the possible research problem asks, how do students experience group projects in online classes? This question explores the human side, how students feel, interact, and cope in digital collaboration. Next, library usage. A good qualitative question here could be, why do some students prefer Google over the university library? Instead of counting users, you're exploring why they make those choices, their attitudes, convenience, and trust factors. The third topic is social media. A possible research problem might be, how do students use TikTok for academic learning? This helps us understand their motivations, strategies, and learning behaviors in a non-traditional space. And finally, customer service. Here, we might ask, how do users describe their satisfaction with online library chat support? The goal is to capture users' personal experiences in their own words. Notice that all these questions use terms like how and why, inviting stories and meaning, not scores or statistics. So when you design your own qualitative question, think about what people feel, believe, or experience, not just what they do.
We've walked through each stage of the research foundation, identifying a problem, defining objectives, developing research questions and hypotheses, and creating operational definitions. We also looked at how qualitative research problems focus on experiences and meanings rather than numbers. Remember, every strong study begins with a clear, well-defined research problem. Your objectives explain what you want to achieve. Your questions clarify what you want to find out. And your hypotheses, when used, predict what you expect to discover. Together, these components make your research focused, coherent, and credible. As you begin developing your own proposals, always ask yourself, what am I truly curious about, and why is it worth studying? That question is the starting point of every meaningful investigation. Thank you for following this lesson. I hope it has helped you understand how to transform a broad idea into a precise and researchable topic. Meet me in our next video, where we'll explore the next chapter, literature review. Until then, keep thinking critically and stay curious about the world of research. Bye-bye.